Thank you. I guess I should have phoned Matthew before I submit my presentation file, because he did a great introduction to my presentation next. So thank you, Matthew. So now I'd like to acknowledge my co-authors, Dr. Lang Fu, Dr. Kwamro Hilda, Dr. Bonnie Liang from AEMERA, and Dr. Zaher Hashisho from University of Alberta. So here's the magic button. Yeah. So I'd like to talk about the background, methodology, results, and discussion, and of course, conclusions. I'd like to focus on the principles of OP FTIR, Open Path Fourier Transform Infrared Spectroscopy, and the site description of the project, hourly results and comparison, as well as select 5-minute non-methane hydrocarbon results and comparison. So, background. Open Path FTIR is a great technology. It's one of the most useful and versatile open path technologies in the market for air monitoring. Under JOSM, AEMERA deployed the OP FTIR in Fort McKay in the oil sands region to support the resolution of odor and air quality concerns in residential communities in the oil sands region, and also help improve the characterization of volatile organic compounds and greenhouse gases emissions from oil sands operations. A little bit of background about OP FTIR. It actually has already over 40 years history. It originated in the 1970s and it became mature in the 1990s. So it has been used by US EPA and other organizations in a variety of areas, such as fence line monitoring and also emissions inventories and others. So in Canada, it has been used by the military, governments, the universities, and even at least one of the oil sands companies here in Fort McKay, Fort McMurray actually. So the advantages of OP FTIR, it can measure hundreds of compounds, especially the hydrocarbon compounds with the detection limits down to a few ppb for some of them. It's automated. Once set up, it can run 24/7 for up to a year with really minimal maintenance. The samples collected are digital and path average, so it allows real-time data processing as well as post-measurement data processing, and it never goes off, right, because they are digital. The cost is low, so essentially I'm saying that you can get more for less. That is something we all love, right? Here's this cartoon is a typical configuration of air monitoring using Open Path FTIR. It is deployed downwind of a chemical plant, the emission source. The FTIR shines an infrared beam toward the retroreflector on the other side of the plume. The retroreflector will reflect the infrared back to the OP FTIR for analysis. So in this round trip, the FTIR takes a picture of the plume and collects the chemical fingerprint information for analysis, so that we can get the concentrations of the chemicals in the plume. A quick mention, I'm just mentioning that there is a demonstration in salons number 5 and 6. If you haven't visited that, do stop by, and Dr. Kwamro Hilda from AEMERA would be pleased to give you a brief introduction, I believe. I think so. It's actually very nice, and it's running and giving us real-time results. So in this project, a monostatic Open Path FTIR was used in Fort McKay, and the standard procedures by US EPA and the ASTM were followed. So here's some site description information. OP FTIR was deployed at Air Monitoring Station 1, co-located with the methane, non-methane hydrocarbon analyzer used by Air Monitoring Station 1 in Fort McKay. If you notice, there actually, I'm not sure if you can read this, the Athabasca River Valley is kind of approximately north-south-wise, and I will talk about this later on during the results and discussion. The sampling frequency was 1 minute per sample, and the path length was 354 meters, so it gives you a path averaged concentration to avoid any sudden change of a point sampling result. So let's talk about the hourly results. In the figure on the bottom, if you can see it, methane concentration from OP FTIR shown as the red color one, and the methane concentration from 55I, this is the instrument used by Air Monitoring Station 1 for methane and non-methane hydrocarbon in total. So they actually agree really well, with the ratio ranged from 0.8 to 1.2, which is fantastic. The average concentration of methane detected was 1.9 ppm. This is the same as in Edmonton. If you look at the concentration rules on the top, you can see that high concentration, by high I mean larger or equals to 2.4 ppm, is mostly detected under south-southwesterly wind. So in order to do more comparison and also study the diurnal variation patterns of methane concentration, we need to calculate composite concentrations. Just to give you a simple example, let's say we have 3 days hourly data, and for each day we have 1 to 24 hours. So to get the composite concentration data point for hour 1, we need to average the data points of hour 1 on day 1, day 2, and day 3 respectively, and we get 2.0 in this case. So now we just learned how to calculate the composite concentration. Let's look at the patterns. So if you look at the figure on your left, consistent composite diurnal variation patterns were observed between the two technologies, the OP FTIR and also the instrument used by Air Monitoring Station 1. So this is very encouraging. The correlation coefficient is high, is 0.94, which is great. So for the figure on the right, as the temperature increased during the daytime, if you can see the red color one, the methane concentration decreased. This is probably because during the daytime, as the ground gets heated up, the degree of mixing and dispersion of air pollutants enhanced, so the concentration actually dropped. On the contrary, at night, the degree of mixing and dispersion may be reduced, and thus the concentration can build up. So in addition to methane, hourly results of N-butane and octane, ammonia, formaldehyde, and also methanol were quantified at ppb level. I just talked about the hourly results, and let's move to the 5-minute results. So non-methane hydrocarbon, as introduced by Dr. Percy yesterday, actually is continuously monitored by Air Monitoring Station 1 using the instrument 55I. It uses a GCFID to separate the methane and non-methane hydrocarbon in total, and then measure the amount of carbon atoms. So to give you an example to understand the methane equivalent, which is reported by the instrument 55I, 1 ppm propane, which has 3 carbon atoms in each molecule, equals to 3 ppm methane. So 55I only gives the total non-methane hydrocarbon information. It does not provide any speciation information. So in contrast, OP FTIR provides speciation information, but it does not measure total non-methane hydrocarbon directly. However, we can still do some comparison. We can use the speciation information and concentration information provided by OP FTIR and do some back calculation. This process is described by a technical report in US EPA by US EPA in 2009. So we came up with the equation to estimate the non-methane hydrocarbon concentrations by OP FTIR. It equals to again, this is reported as methane equivalent. It equals to 4 times the concentration for N-butane, because there are 4 carbon atoms in each molecule of butane, and plus 8 times N-octane. Again, there are 8 carbon atoms in each molecule of N-octane. So if the alkenes are truly a mixture of N-butane and N-octane, and I know that this is a big if, I'll talk about it later on. So this is my favorite part. If you look at the figure on the bottom, you'll notice that the non-methane hydrocarbon episodes detected by Open Path FTIR and the non-methane hydrocarbon episodes by 55I, they agree really well with each other. And for the top figure, the time series of wind direction, it gives information that the episodes of the non-methane hydrocarbon were mainly detected under northern wind. So if you recall the Google map that I introduced earlier, and also Matthew's presentation earlier, the Athabasca Valley channel actually is north-southwise. So probably or possibly the air emissions was channeled down south to the monitoring site. So what if the plume is not a mixture of N-butane and N-octane? Instead, it may be dominated by propane instead. So in this case, we need to modify or adjust the factors used in the equation we discussed before. So now we have the equation as 3 times the concentration of N-butane reported by Open Path FTIR plus 0 times the concentration of N-octane in the scenario of a plume dominated by propane. So in this case, the concentration trends determined by Open Path FTIR and 55I were even more consistent. So generally speaking, non-methane hydrocarbon concentration trends were consistent for the major episodes observed. And Open Path FTIR was a complement to 55I at AEMERA with speciation information. Fortunately or unfortunately, no odor complaint was recorded in Fort McKay during the field campaign, according to an incident summary given by the environmental management system. So here's a closer look at the major non-methane hydrocarbon episode and the methane concentration trend observed for the same time period on September the 6th, 2014. The correlation coefficient between non-methane hydrocarbon by Open Path FTIR and non-methane hydrocarbon by 55I were excellent. The efficient was 0.95, which is highly correlated. But if you look at the concentration of methane trend, the trend, and the non-methane hydrocarbon trend, they are not really correlated with each other, indicating that the sources of methane and non-methane hydrocarbon are probably separate. So to conclude, the average methane concentration was 1.9 ppm. This is the same as in Edmonton. And high methane concentration were mainly detected under southwesterly wind. And VOC and also ammonia were quantified at ppb levels. Methane and non-methane hydrocarbon results were consistent between Open Path FTIR and the instrument used by Air Monitoring Station 1. So Open Path FTIR demonstrated its capability in monitoring multi-compounds simultaneously and continuously. More field campaigns for longer time periods in the oil sands region are necessary to have a better understanding of odor events and complaints, and also the air emissions from oil sands operations. So I'd like to express our sincere thanks to AEMERA for the funding support, OBIA for the field support and data sharing, and the AITF for the logistic support. Thank you. Any questions?